So for example 1, let's answer these questions for me. What is the size or dimension of matrix A? How about matrix B? How about matrix C? What about matrix D? The sizes shouldn't be all that difficult for you to come up with. I can see here I have 3 rows. This is a row, this is a row, this is a row, so 3 by column, column, column. So it's 3 by 2. And I can see B has the same number of rows and columns, so it's also 3 by 2. C, I have 1 row, 2 rows, 3 rows, so 3 by 1, 2, 3 columns. So it's a 3 by 3 matrix, square matrix, and so is D. There's a plus sign missing here. Let me put it in there really quick. It's asking you a question here. Why doesn't this matrix A plus C not exist? Well, remember, for me to add 2 matrices together, or subtract them for that matter, they have to have the same number of matrices. The dimensions are not equal. So with that being the case, I cannot add the 2 matrices together. So now compute A minus B. Well, I can see here that, again, A was a 3 by 2 matrix, and so was B. They're the same size, so I should be able to do that. The only thing you have to kind of be wary about is make sure that you're distributing properly. If I'm going to be doing, A minus B, that means that each term, like this minus this, so -1 minus 2 would be one of them. So if I had those 2 matrices being subtracted, then, I'm going to have -1 minus 2, 3 minus 3, 4 minus -2 in the first column, 2 minus 4, -2 minus 1, 0 minus 2 in the second column. And if I simplify all those, this is the matrix I get. When I do like adding and subtracting constant multiples of matrices, I have to make sure I am following the order of operations as well. I have 2 times that matrix, -2, -1, 3, 4, 2, -2, 0, when I read across the columns. 3, 2, 3, -2, 4, 1, 2, reading across the columns, being multiplied by 3, and then I'm subtracting. So if I do the scalar multiplications, the first matrix has columns -2, 6, 8, and 4, -4, 0. The second one, as you see here, what you're seeing here is I distributed the -3, so that's why there's a plus out here now. But all the numbers inside the matrix got multiplied by -3, so I have -6, -9, 6, and -12, -3, 6 in the columns. And when I add them together, -2 plus -6, 6 plus -9, etc., etc. Numbers in the same positions all across the board. And so when I get my final answer, the first column would read -8, -3, 14 from top to bottom, and the second column would read -8, -7, -6, going from top to bottom as well.